So while they are setting up, the next one is from a bit of a different organization. This is from Boskalis, a very large Dutch dredging company. And they're a bit of a different kind of player than most of the industry speakers we have here. Instead of pushing technology, they are more a consumer of technology, robotics technology. So they will talk a lot about, I think, the kind of use cases that they have where they would like to have robotic solutions for. So this is really an attempt to connect with you. But I'll give the floor now to first Sebastian Henrion and then Harold van Heukelum as well. Let's give them a hand.
Thank you very much. Aha, yes, we're there. Okay, well, good afternoon all, and thank you, ICRA at 40, for having us. My name is Sebastian, this is my colleague Harold, and we work at the R&D department of Boskalis. We're mainly focused on work on the intersection of AI, data science, simulation modeling, and robotics. And as you might have noticed from the slide behind us, we're not your standard big robotics company. So that's exactly why we're here. So in short, I'll present a glimpse of what we do as Boskalis in general, and then we'll tackle some topics which we do at R&D on robotics and automation, and also mention some of the challenges we face there. And then, well, we have a booth here at the exhibition floor, so if you do see room for improvement or collaboration, please get us a visit. So what do we do? Well, first of all, with our large fleet of dredgers, which are basically vacuum cleaners on the sea, we create innovative infrastructure to enhance transportation and improve connectivity all over the world. So what you see on the right-hand side, well, for you on the left, I'm sorry, is basically a very large land reclamation in the Philippines, where on top of it there will be an airport built. And on the right-hand side, you see a picture of the Fehmarnbelt Tunnel, which is a 20-kilometer submerged tunnel that will connect Germany with Denmark. A large part of our company is busy with the ambition to shift from fossil fuels to renewable energy. So what you see on the left-hand side is a heavy lift vessel which installs monopiles. These monopiles, we can transport them themselves all over the globe with our own transportation vessels. And before a monopile is installed, we have rock dumping vessels which are used to level the seabed. And after the monopiles get installed, we use rock to prevent erosion at the foundation of a monopile. So to make sure you get an impression of the scale we're talking about here, the diameter of such a monopile is basically the length of this stage. And the length of the monopile is 120 meters. So that's usually also the scale at which we work, which makes it a challenge to introduce currently state-of-the-art available robots. Another part of what we do is protect the hinterland through climate adaptation measures. So you can think of preventive measures against coastal erosion and flooding. As we do a lot of beach replenishment, here you see a photo of 3 hopper dredgers rainbowing at the coast of Texel, and we do reinforce dikes, which you see here at the Markermeer. Another one, a very small but a very visible part of our company, is basically our salvage department, where we protect the ocean from pollutants, which can have a consequence from maritime disasters. So a good one that was in the news is basically the dismantling of the FSO Safer at the coast of Yemen, basically in a war zone, or the towage of a burning car carrier at the coast of the Netherlands with more than 4,000 electric vehicles in it. And as a last one, we try throughout our projects, we try to incorporate a lot, and a lot of effort goes into biodiversity and ecosystems. So as you can see here, we built, with the local communities, we built a sustainable coastline with mangrove protection in Java. And we print our own artificial reefs with a 3D printer at Papendrecht and install them, well, in this case, at the bay in Monaco. So I'll give the clicker to Harold to continue.
Thank you. So what we see throughout our company, robotics, more and more gains ground. And that's primarily driven by 4 reasons. The first is an ever-driven or an everlasting need to increase safety on our projects. Secondly, we see that our workforce gets older, and we want to employ our employees where they have the most impact and leave the tedious and simple jobs to robots. Thirdly, with also the energy transition and climate adaptation, we see more projects, so we need to increase our efficiency to keep up with the increase of projects. And fourth is that we want to increase and embed sustainability more in our company, and robotics can play a role in this. In the next couple of slides, I will show, or we will show, previous attempts of implementing robotics in our company, and we also touch upon some of the challenges we see here. So on safety, we work with quite a lot of big assets, and limiting interaction between these assets and human is a quick win for safety. So one of the things we did is, okay, if we have mooring operations, so getting one vessel beside another, can we limit the interaction with humans there? So can we move to a remotely operated system? And that is what you see here. So that ball gets attached still by a human, but the rest of the operation, pulling the vessels together, is done by remote controlled operations. Or secondly, if we see in the underwater domain, we sometimes come across areas where there is no visibility. We cannot deploy divers, we cannot deploy simple or general ROVs, and normal acoustic sensors are not working due to confined spaces and interaction with walls, etc. Can we move to tactile imaging? That's one of the questions we're currently working on. On the area of efficiency, we want to move or have more information, more measurements on, for example, turbidity plumes. So during dredging operations, some of the sand we try to dredge up gets spilled and is suspended in the water column, and we need to model this, or we want to improve our modeling of this so we can mitigate this, because we want that. So swarms might be one of the solutions for this. And we're currently looking into, can we build a simulation environment for these operations so that we can show people within our company what our ideas are and also quickly iterate over the ideas we have. And another one on efficiency is, can we use machine learning to detect damages from images or from videos, see what the interesting parts is, and then send divers only to those interesting parts instead of having a diver scanning every square centimeter of a wall, which is takes a lot of time and it's not that most efficient.
Okay, thank you. Well, the third area is workforce, and with the aging of our people and the more complex tasks they get, we're looking in more autonomy in our operations. So we did a test. We converted a manned small survey vessel into an unmanned vessel with the help of an American scale-up sea machine robotics. And basically what we want to see is how easy the conversion goes and how good it sailed compared to the captain. Well, it took me and an E&I colleague 7 days to prepare the conversion, 3 to 5 days to commission. And we did the tests on the Markermeer, where there is basically this actual inland shipping, a collision avoidance test, following a boat, blah, blah, blah. And in the end, the captain was very happy to tell us that the machine didn't outperform him. So, well, case closed, I guess. That's not true. Another one, which we work together with the ROMLab with, is basically that this is a large cutter dredger, and the cutter which you see at the top right is lower down and it sucks up soil. And the teeth which are on top of this cutter, they're wear. So you see here 10 people standing in front of the cutter to change these teeth when they are worn out. So we did an exercise. If we could help these people to maintain their physical health, to just not lift weights of 30, 35 kilograms every 10 minutes, by researching different robot arms or pulley wire systems to assist them. And then the last category is sustainability. We were a part of the Robotics consortium, which was a national consortium of TNO, Rijkswaterstaat, and University of Twente, where we investigated the ease of building up a digital underwater twin to see how easy it is to do predictive maintenance. So basically predict when you need to do maintenance and lower costs, instead of being surprised when an underwater assets break down and then costs go into the millions. And the last slide on sustainability is something that we are currently investigating, which is instead of pulling open a can of volunteers, which on muddy sand are injecting seagrass seeds to have seagrass over acres of land, can we do that robotized? So any suggestions are welcome. So I think with this one, we go to the last slide.
Yeah, so basically we want to end with a call to action. We're not here to show amazing implications or implementations of robotics. You are bright minds, you see our challenges. Hopefully you have good ideas to overcome our challenges. So we want to invite you to come to our booth, booth 7, the one without any robotics on it. And we hope to see you there. So thank you for your attention.